So you can quickly skip these things and move to the slide 3. Just a second. Move to the slide 3, which is what is HSDPA. So HSDPA is a scheme that supports a very high capacity shared data channel in downlink direction. So HSDPA is basically based on the following principles. So these were the new things that were introduced with HSDPA. So the first thing is fast scheduling, the 2 millisecond based scheduling at node B. So earlier, like scheduling the TTI, if you talk about the transport format for the UMTS calls used to be 10, 20, 40 and 80 milliseconds. So that means after every 10 milliseconds or 20 milliseconds or 40 or 80 milliseconds, the data would be picked from that DCH and sent to the UE, or similarly in the uplink direction, the data would be picked from the UE's MAC layer and use RLC layer basically, and it would be sent by the MAC over 5 towards RNC or node. So it used to be like 10 milliseconds and those things. So now it has been changed to 2 milliseconds. That means the scheduling would be happening after every 2 milliseconds. So this is like fast scheduling. So how it helps is like it in the downlink direction. Again, the new technique that was introduced is adaptive modulation and coding, which is like link adaptation. So based on the feedbacks that the node B gets from the UE, it takes the decision of after every 2 milliseconds which UE to be scheduled, and what would be the modulation and coding parameters of that UE. Then we would quickly cover these things. So next is the introduction of HARQ. So this was a hybrid ARQ was introduced in the HSDPA. So it is hybrid ARQ is just to give a quick thing that earlier it used to be like a ARQ mechanism from the RNC layer. It used to be a stop and wait mechanism. So now there are parallel n process HARQ, which is generally I think 8. So that is the value taken there. So there would be 8 parallel ARQ processes running in the node B, which would be implementing the ARQ mechanism for the data transfer. So that means that for whatever data we receive an error or don't receive an ACK, so for those things there would be a layer 1 based retransmissions. So the retransmissions which were earlier like RNC happening from RNC would now happen from the layer 1. Okay, then let's move to the slide number 4. So we would try to cover this at a very superficial level, so that the purpose of giving this demonstration is solved, rather than going into details and about the technical topics and not going into. I might be going a little bit fast, but I would like to wrap up these things in another 5-10 minutes. That's why. Okay, so the next slide is slide number 4, in which I have shown the codes that are being used for the HSD-SCH channel. So basically the spreading code used for HSD-SCH is 16. So if we see the orthogonal codes structure that we have, so we have like 16 ports available for this 16 spreading factor. So at maximum 15 ports can be used for the HSD-SCH. One anyways has to be kept reserved for the SRB purpose. So we cannot use all the 16s for the HSDPA. So one has to be used for the SRB. So maximum of 15 can be used, but generally in the real networks, less than 15 ports are used. 5, 10 or probably something of that order. So we can move to the slide number 5. Here I have I'm on the slide number 5. So I have just tried to capture a little bit about what all channels were introduced in the HSDPA. So HSDPA, if you see the diagram, in the downlink